Money, big money, graph, increase that tank. Let's make money with optimization derivatives. Yay, we don't throw away money for school. So, you're a businessman, woman, whoever you are, you wanna make profits, right? Answer derivatives. Derivatives tell you where the peak is and the not peak. We wanna find peak because it is money in there and it can be included in the real graph, stock graph, whatever graphs you want, anything that can be measured. It can also bring money. We also need to know the not peak because it is the lowest points in the graph and we need to know what our worst moments in the business so we can improve for the next time we run the business.
So, in the illustration given above, the meaning can be drawn that application of partial derivatives refers to the practical use of partial derivatives in solving problems involving functions with multiple independent variables. A partial derivative measures the rate of change of a function with respect to one variable while keeping other variables constant. This concept is widely used in various fields to understand relationships between variables and optimize outcomes. Terms in the graph: absolute or global maximum of F4 is on the top C, and absolute or global minimum of F -4 is on the bottom of D. Local maximum of F1, local minimum of F-1, A is a maximum turning point, B is a minimum turning point. A, B, C, and D are extreme points. A and B are local extremes, while C and D are global extremes. 4, -4, 1, and -1 are extreme values.
But how do we know what is the local maximum or minimum are? Well, we use stationary point because it is a candidate for relative extreme. Syifa, go explain it.
Types of stationary points. A is a local maximum point. At A, f prime equals 0, and f double prime is less than 0. B is an inflection point. At B, f prime is equal to 0 and f double prime also equals to 0. C is a local minimum point. At C, f prime equals 0 and f double prime is more than 0. Inflection point is the point where both points are 0.
Okay, this is my turn to find the local extreme values, maximum or minimum, of the function. I'll calculate this derivative set it to 0 to find critical points and then determine the nature of these critical points using the second derivative test. Here's the step. Okay, we're going to move to the second step. Here's the step to find its local extreme values, maximum or minimum. We first found the critical points by setting its derivative equal to 0, and then this gives us two critical points. Okay, finding the stationary points or critical points. We put the formula into the first derivative, so we got the 3x squared minus 12x plus 9, and then set fx to 0. And solve for x is becoming 3x squared minus 12x plus 9 equals 0. After that, we have to subtract, and this gonna be simplifies to x squared minus 4x plus 3 and equals to 0. And the factor is becoming to x minus 1 and x minus 3. It means that x1 is equals to 1 and x2 is becoming 3. Here's the step 3. Is searching for the second derivative, is indicating a local maximum and from x1 it's equal to 1 and the x2 is equals to 3 and is indicating a local minimum points. You can see here we got the second derivative from the first derivative. The second derivative 6x minus 12, and then it's gonna be 6 times 1, and then minus 12 is minus 6 is a local maximum, and then we're going to the other x is 3 equals to 6 times 3 minus 12 is 6, like it's gonna be local minimum. Last step is step 4 is calculating the local extreme values. Finally, we substitute these critical points back into the original function. We have to substitute the critical points back into the original function. It's to find the corresponding local extreme values. First thing first, we have to put the formula, and then we got x power of 3 minus 6x squared plus 9x plus 2. And then we put the x1. And it came 1 the power of 3 minus 6 times 1 squared plus 9 times 1 plus 2, and then it's gonna be 6. Alright. So the local maximum is 6, and we're going to another x. So it's becoming 3 the power of 3 minus 6 times 3 squared plus 9 times 3 plus 2. It's equals to 2. So, and we got the local minimum is 2.